Hey there, I'm Dave Hearn, and I'm the director of Kissimmee Park Observatory. In this Star Hopping Extra, we're going to take a break from our normal routine and learn about the different types of galaxies, all the different shapes and structures that these massive island universes can have, and how they might appear in your telescope eyepiece. More about this great stuff right after this. Stay tuned. Hey, hello, hi, and welcome to episode 15 of Star Hopping with Kissimmee Park Observatory. I'm Dave Hearn, and I'm absolutely thrilled to be your host. In this series of programs, we'll show you the most beautiful sights in the night sky and explain exactly how to find them with your binoculars or your telescope. As I was reviewing the star charts and preparing for this episode, it became very clear that we needed to wait a bit for the stars to rise some more. There are many deep sky objects sitting either on the horizon or low in the sky around the 10 p.m. time frame. In a fairly short period of time, we will be very busy. As I mentioned in the last episode, the great majority of the targets are galaxies, and to see them well, it's necessary to let them get to a reasonable altitude of about 30 degrees or more. This allows the faint light coming from these grand celestial structures to pass through a thinner section of our atmosphere. When deep sky objects are low, their light is diminished by the longer atmosphere, just as the sun dims and starts to appear orange and red as it sinks closer to the horizon. When they are higher, they appear brighter and they're easier to locate. When they are at or near the zenith, they are about as bright as they can get. Generally, you should just be patient and wait for deep sky objects to rise a bit before hunting them down in your telescope. So we're going to postpone for a week before we start checking out all the new targets in the constellations of Lower Ursa Major, Canes Venatici, Coma Berenices, and finally Virgo. So what do we do in the meantime? Let's get acquainted with all the different kinds of galaxies and discuss all the different types of shapes that galaxies can take. So there are four main types of galaxies with subclassifications in each. The main types are elliptical galaxies, spiral galaxies, spiral-barred galaxies, lenticular galaxies, and irregular galaxies. So let's have a look at the first type, ellipticals. One of the most famous elliptical galaxies is Messier 87 in Virgo. Elliptical galaxies are shaped like an elongated sphere. In the sky, these galaxies look like oval-shaped disks. The light is smooth, with the surface brightness decreasing as you go farther out from the center. Elliptical galaxies are given a classification that measures their elongation from a perfect circle, otherwise known as their ellipticity. The larger the number, the more elliptical the galaxy is. So for example, a galaxy of classification of E0 would appear to be perfectly circular, and a classification of E7 is very flattened. So the elliptical scale varies from E0 to E7. Elliptical galaxies have really no particular axis of rotation. The next type of galaxy is the one that most people are familiar with, the spiral galaxy. A perfect example of a grand design spiral galaxy is the Pinwheel Galaxy, also known as Messier 101 in Ursa Major. A grand design spiral has spiral arms that wrap symmetrically around the galactic core and are usually very long. Another well-known spiral is Messier 81, which we recently saw, also in Ursa Major. Spiral galaxies have three main components: a nuclear bulge, a disk, and a halo. The bulge is a spherical structure found in the center of the galaxy and contains mostly older stars. The disk is made up of dust, gas, and younger stars and forms the familiar spiral arm structures. The halo of a galaxy is a loose spherical structure located around the entire central structure of the galaxy. The really interesting thing about spiral galaxies is that since they are essentially huge disks of stars, they have a flat pinwheel shape. This shape presents itself in different ways depending on the three-dimensional orientation of the galaxy as seen from our point of view. If you take that disk and rotate it that our perspective only sees the edge, what we view as a needle galaxy or edge-on spiral. A perfect example of this type of view is NGC 4565 in Coma Berenices. These are awesome deep sky objects and are usually very impressive in the eyepiece because it's easy to see the needle-like shape slicing across your eyepiece. Another famous edge-on spiral is the Sombrero Galaxy in the constellation of Corvus the Crow. In this object, it's easy to see the bulge of the central core of the galaxy and the edge of the disk cutting across the core. A galaxy that is partially tilted shows less of its structure, but creates another amazing perspective, and a great example of this is the famous Andromeda Galaxy, Messier 31. A second classification of spiral galaxies is the barred spiral galaxy type. We recently saw the best example of one of these in NGC 1365 in Fornax. These galaxies have a central bar that form the core of the galaxy. Then two arched and twisted arms connect to the ends of the bar and curve around the galaxy in opposite directions. In both regular and barred spirals, the objects are given a special classification according to how tightly their arms are wound around the core. The classifications are A, B, C, D, etc., with A having the tightest arms and the arms getting looser as the letters increase. Halfway between an elliptical and a spiral galaxy is a lenticular galaxy. This type of galaxy has a central bulge and a disk like a spiral galaxy, but there are no discernible spiral arms. A good example of a lenticular galaxy is the Spindle Galaxy in the constellation of Sextans. The last type of galaxy we'll discuss is the irregular galaxy. These strange galaxies have no regular or symmetrical structure. A great example of an irregular galaxy is the Large Magellanic Cloud, a galaxy orbiting our own Milky Way. Another good example is Messier 82 in Ursa Major, which we saw a couple episodes ago. There are two types of irregulars. Type 1, in which we see lots of activity in star-forming regions, and Type 2, in which there is so much obscuring dust that very little can be seen. In Messier 82, a Type 1 irregular, we can see that there's certainly some great cataclysm going on in its core. I'm sure that if you were unfortunate enough to be on a planet nearby, the weather forecast would be very strange indeed. So that's our review of the different galaxy types. Hopefully this will be useful with the loads of galaxies that we'll be studying over the next few weeks on star hopping. First, we learned about elliptical galaxies, which are oval groupings of millions of stars. Next were spiral galaxies, which can appear either as a majestic pinwheel in the sky or needle-like edge-on wonders. Then we talked about spiral barred galaxies that have a central bar with the connecting arms wrapping around the core. Then lenticular galaxies that are a cross between ellipticals and spirals. And finally, we thought about irregular galaxies that can't be classified into any of the previous types and are usually very strange places indeed. The distance and scale of these lonely island universes are, to employ a very overused adjective, truly and absolutely awesome. I hope you've enjoyed star hopping around the Milky Way. We'll continue to bring you these video astronomy tutorials every week on Thursdays and in their podcast format on Fridays. They'll be designed to help you find deep sky objects that are up in the sky at the time we post them on the internet. The reason we create these videos and podcasts is to help beginning amateur astronomers learn the sky and get more enjoyment out of their telescopes and astronomy in general. If you have any requests or suggestions of potential targets in the night sky that you'd like to see us present, just let us know down in the comments section below or on our website blog. If this is the first time you're checking out star hopping, and if you found this video useful, please consider subscribing to our channel by clicking the big yellow button down there. Click the thumbs up on the video, and please share this tutorial out to your friends who like looking at stars. Also, as I mentioned, please feel free to leave any questions or comments below, and we'll be sure to respond as quickly as we can. Also, please follow KPO on Facebook, where we post all of our astrophotos and keep everyone informed about upcoming astronomical events. We'd love to hear from you to discuss all this great stuff up in the sky. All the links to these places in cyberspace, including our website, kpobservatory.org, can be found below in the episode notes as well. And finally, if you feel this video provides you value and you'd like to see more, please consider supporting us on Patreon, where for a small amount per video, you can support our efforts and help us make even more great astronomy tutorials just like this one. Well, thanks again for watching, and we'll see you next time on Star Hopping with Kissimmee Park Observatory.